Greetings from Rohini College of Engineering and Technology. I am Professor Radhika from Chemistry Department. In this lecture video, we discuss about the nuclear energy and nuclear reactor. After the completion of this topic, students can able to explain the need and importance of non-conventional energy sources. Now we discuss about the nuclear reactor. Reactors which are designed to carry out nuclear reactions for the generation of heat, electricity and radioactive isotopes are called nuclear reactors. That is an equipment in which the nuclear fission reactions takes place in a controlled manner is known as a nuclear reactor. So the nuclear reactors are generally called as light water nuclear power plant because here the uranium-235 fuel rods are submerged in water. Here the water acts as a coolant and moderator. Let us see the components of light water nuclear power plant. It consists of 7 important components. One is fuel rod, second one is coolant and moderator, control rod, pressure vessel, protective shield and turbine. This picture indicates the model of nuclear reactor. Let us see the working principle of each kinds of components in the nuclear reactor. The first one is fuel rods. The fuel rods are made up of uranium-235. The fissionable materials used in the nuclear reactor is enriched uranium-235. It is used as a fuel in the reactor in the form of rod or strips. Uranium-235, plutonium-239 are used as a fuel rods. Its main function is it produces heat energy and also neutrons, which helps to start the nuclear chain reaction. The next component is control rod. To control the fission reaction, the movable rod which is made up of gadmium or boron. These control rods are suspended in between the fuel rods. That is the arrangement of one fuel rod, control rod in this alternative way. These rods can be lowered or raised and control the fission reactions by absorbing the excess of neutrons. If the rods are deeply inserted inside the reactor, which absorb more number of neutrons and the reaction becomes very slow. On the same time, when we pushed out the rods, which will absorb less number of neutrons and the reaction becomes very fast. Normally, the gadmium and boron rods are used as a control rods, which controls the nuclear chain reaction and avoid the damage of reactors, because if we are not absorbing the excess number of neutrons, the reactor becomes explode. So in order to avoid the damage, these control rods are used. Then the third component is a moderator. So moderator is nothing but it is a substance which is used to slow down the neutrons are called moderators. When the fast moving neutrons which collide with moderator, it readily lose energy and gets slowed down. So normally the ordinary water, heavy water, graphite and berylliums are used as a moderator. Its main function is it reduces the kinetic energy of fast moving neutrons to slow neutrons. That is nearly the 1 million electron volt is reduced to 0.25 electron volt. Then the fourth component is a coolant. That coolant is used to absorb the heat produced during the fission reaction. Normally, the coolant is in the liquid form which is circulated around the reactor core. It enters the base of the reactor and leaves at the top. The heat carried out by going liquid is used to produce the steam. Its main function is it cools the fuel core. Normally, water, heavy water, liquid metals are used as a coolant. Then pressure vessel. Pressure vessel encloses the core and also provides the entrance and exit passage for the coolant. This pressure vessel helps to withstand the pressure as high as 200 kg per centimeter square. The next component is a protective shield. The nuclear reactor is enclosed in a thick massive concrete shield which helps to protect the lives of all in case of leakages of radiation. And turbine, the steam generated in the heat exchanger, is used to operate the steam turbine which derives a generator to produce electricity. So the components of nuclear reactor is very important. Each components do their function. Therefore, the radioactive substance, from the radioactive substance we can produce the electrical current with the help of these components. Next we move to breeder reactor. So breeder reactor is nothing but it is a reactor which converts the non-fissionable material into fissionable materials. Okay, so non-fissionable materials, the best example is uranium-238 and thorium-232, which are converted into uranium-235 and plutonium-239 respectively with the help of breeder reactor. Okay, so the non-fissionable materials are otherwise called as a fertile material. Fissionable materials are known as a fissile materials. Okay, the conversion of fertile into fissile material is called as a breeder reactor. In breeder reactor, the neutrons emitted in the fission of uranium-235 is used to propagating the fission chain with uranium-235. So in this way we are converting the non-fissionable materials into fissionable materials. Here the uranium-238 is converted into plutonium-239 with the liberation of neutron plus fission products containing more than 3 neutrons. The main significance of this breeder reactor is it's a non-fissionable nuclide such as uranium-238 and thorium-232 are called fertile nuclides which are converted into fissile nuclides. As regeneration of fissile nuclides takes place, its efficiency becomes more. So the conversion factor for breeder reactor is greater than 1. The conversion factor is calculated by the formula number of secondary fuel atoms produced divided by number of primary fuel atoms consumed. So, okay students, thank you for listening.